we have these three figures, figure A, B, and C. You're going to look at different potential side lengths for your figures. Those side lengths for the square portion are going to be 4x, 4x, and x plus 3. Now, you might notice as they progress, they seem to be more challenging. But I'm going to encourage you as you approach this, you don't approach it as what do I do? You approach it as what do I know? So if I'm looking for area, what am I always going to be doing? Yeah, base times height or length times width, or side squared. I like how you, right, there's all squares, so we can square whatever the side length is as well. That principle does not change as your side length changes. That same principle is at hand. So the only way to do poorly is to copy or not do it, right? You're going to see, and I would say do each row at a time. Do all of row with 4, do all of row with x, and you'll see things build a little bit. So this should take, I'm thinking about 6 to 8 minutes with your partner. So checking out figure A. If a side length is 4, the area is 16. And if I take 1 away from that, and if I double 16 and add 1, I kind of rolled through that one because I thought that would be easier. Although, again, same concept for all of them, right? So if I have a side of x, x times x, take 1 away from that, double it and add 1, 2x squared plus 1.
Okay. X squared plus x plus 1. What about x?
Yeah, I just want to be simplified.
Yeah.
Because I see what you're saying.
Wouldn't you wait, this right. Wouldn't you have to do the multiplication first, so you couldn't simplify it? Because you'd have to
Well, x. So it's like if it's x, right? This is x times x for x squared. So this one's x squared area of 1. So x squared plus 1 works because x squared plus 1 is 2x squared plus 1. It's the same thing. Okay, this next one, we got a 4x. 4x times 4x is 16x squared. And so some people chilled on this. Watch, let me prove it. That's 4 times x times 4 times x, right? There's 16, there's x squared.
Wait, would that make squared minus 1 or would 4 times?
For B, who can tell me what the only difference is? What's happening here, Vinny? Yes, I'm just going to take 1 away. And someone help me out with C then, right? So it'll be 32x squared plus 1. So 16x squared and 16x squared is 32x squared. So that plus 1 got in there early on, maybe, or something. But it has to be like terms to combine. Okay, last one. X plus 3 as a side length. What's figure A? Don't be afraid to go out on a limb. I know this one's tougher. Yeah, Ivy?
Well, I did the thing where I in the
Oh.
normal distributed product.
You did this times this?
Yeah, so I got x squared plus 6x.
This would be x squared plus 6x plus 9.
What?
Well, I can show you quick. Right there is x squared plus 3x. Right here is 3x plus 9. So there's my 6x.
I distributed the x.
That's all right. I'm glad you tried it. The one that's more common that I've seen today is this. Or x plus 3 times x plus 3. Brandon?
So
Let's check out area of B. It's just whatever A is minus 1, right? I started writing the wrong thing. Does everybody go with B? Whatever A is minus 1. And then C is just 2 of whatever A is plus 1. So you could write it as 2 of these x plus 3 squares and then plus 1. Again, it's all just base times height. And we can combine some things we can't. Notice we got a lot of square things happening, which means they're probably what kind of, yeah. We keep seeing those squares popping. Squares keep popping up in all these patterns. So, you're going to get step 5 and 18. I don't suggest you draw 18. I say you explain what it'll look like, okay? Then, you're going to say how many small squares are in each and explain how you know that. Work on the equation, and then sketch some graphs for n squared minus 1. You got about 10 minutes with your partner for this. So I'm going to have to write a little tight here. But who can, I'm going to choose to do 1 and 2 together, and I'm just going to use the description, kind of. Who can describe to me how these things are changing? And then I'm going to use that to get the visual. Elsa? Okay, so I'm going to have a 5 by 5. Okay? And then those 4 on the corner. So that's kind of like, do you see how I'm kind of putting 1 and 2 together? Instead of drawing it, I'm explaining it's going to be a 5 by 5 square with 4 individuals on the corner. What about step 18, everybody? Or not everybody, one person. Who wants to tell me about step 18? What's that going to be like? Maddie?
18 by 18.
It's going to be an 18 by 18 square in the middle and then 4 on the outsides. Oh, yeah. Here's what I'm going to do. 18 by 18. 1, 2, 3, 4.
It's not Swiss time though.
No. So, next. How many small squares in step 5? Who can tell me how many? 29, thank you. And step 18? 328. And so who can give me the equation that they wrote that would represent how they change? Sean?
Y equals n squared plus 4.
Yeah, it's always the square in the middle is the number of steps squared, and then 4 more on the outside every time, n squared plus 4. And this square tells us this function is probably quadratic. Yes. All right. So this next one, I had a good time walking around. I saw some different squares out there, and I saw some that weren't squares. And then we chatted. If it wasn't a square to start, I think while you could have the right number of little squares, I don't know if it'd represent the situation. Like, there would be the visual flow, right? So who can explain what their squares look like?
Well, I started for step 1, it was nothing because 1 squared minus 1 is nothing.
Yeah.
And then for 2, I just drew a 2 by 2 square and then erased the corner.
Okay.
And then for 3,
That's the one you did, right? You missed the top right, right?
yeah. And then for 3, I drew a 3 by 3 square and erased the corner. And then 4 by 4 and erased the
Oh! So essentially, you made a square by the number of the step. So 4 by 4, and you yeeted the top corner out of there. That's the technical term. Okay. And then that was how many squares there were.
Yeah.
I did it different. I yeeted the bottom left corner. All right.
Doesn't matter.
Livia yeeted the bottom right corner. Anybody do top left?
It's just gotta be 1.
It doesn't matter which corner you yeet.
Top left.
You just need to yeet one.
You just gotta eat 1.
Yeet.
What is the plural?
Yeets.
That is not the plural.
Yeet.
Not the plural.
Top left?
Yeah.
Okay, there's top lefts, there's top rights, there's bottom rights, there's bottom left, but it doesn't matter, it's all just a square missing 1. And what's cool is, look at, that's what the function says. There's a square, we're missing 1. I think that's cool. Here's our next pattern to consider. You're going to say how it's changing, get the next step, and then what I would challenge you to do, don't even look at 3. I know I just said that, and now you want to look at 3. But what I want to challenge you to do is try to write a function before you look at given functions. Okay, cool. All right, get after it. Grow in steps. Who can explain to me what they drew for step 4? What did you draw for step 4? All right, Ava.
I drew a 4 by 4 square and then
It was 4 by what?
4 by 4 square and then I added 2 rows of
Okay, I like how you explained that. 4 by 4 square. And then you added 2 more rows there. Okay. Something like that. Not pretty. But there it is. Okay. I like, so another way to say it, it would be a 4 by 6. 4 by 6 could be another way to say it, right? We all vibing? Okay? Now, Kieran says it's linear because it's going 1, 2, 3, 4 on the base, and it's going 3, 4, 5, 6, 1 by 1. So linear?
No.
No, 1 degree or 1 in 2 different degrees is squared. The area gets squared, right? We know that from, remember way back we did,
It does go up by 1.
it goes up by 1 in 1 dimension, but it goes up by 1 in 2 dimensions, which is
So it's not
squared.
linear. He's right
Okay.
on the second part.
So Kieran is wrong. They do increase by 1, but not linear. area is squared. Right? We can think back to our geometry, volume, surface area stuff, right? Okay? Now, raise your hand if you think Diego is right. Raise your hand if you think Jada is right. Raise your hand if you think neither of them is right. Raise your hand if you think they're both right. All right. So let me prove to you why they are both right.
Oh, yeah. You gotta distribute.
So that is one way. You could say n times n plus 2 equals n squared plus 2n.
Yeah, you just gotta distribute.
I prefer to look at how the pattern's changing, and we can justify it with both of these. The one that I see it with is the second way. This is the one I see. So I see the square and then 2 more rows. I see a square and then 2 more rows. So that's what I saw. So a square, or is that a square plus 2 more rows? Now this other one also makes sense. Did you notice the base is always the number of the step?
Yeah.
So that's n. The height was always 2 more than the number of step. That's n plus 2. So base n always works. And this is always n plus 2. Base times height is n times n plus 2. So I see that as well. But I'm inclined to look for the square and then get the 2 rows